2011, number 3. No calculator on these ones, on the rest of this test. R is a region of the first quadrant enclosed by the graphs of 8x cubed and sine of pi x, as shown in the figure above. Write an equation for the line tangent to the graph of f at x equals 1/2. Okay, it's kind of up to you to know which graph is which. So 8x cubed is going to be this guy. That's f, and sine of pi x is this guy, so that's g. And so we want the tangent line of f at x equals 1/2. Well, that's this point right here, so we're looking for the tangent line right there. Okay, so A. To find the tangent line, we need to know a couple things. We need to know the point, so I know when x is equal to 1/2, y is equal to 1, and I need to know the slope. So what is f prime of x is equal to the derivative of that, so it'd be what, 24x squared. So at 1/2, f prime of 1/2 will be 24 times 1/2 squared. 24 times 1/4, which would be 6. So the tangent line would be y minus 1 equals 6 times x minus 1/2. Okay, there you go. B. Find the area of R. Okay, area of R. By now you probably ought to be good with just saying it's the top function minus the bottom function. So it's the integral from 0 to 1/2 of g of x minus f of x dx. So that's going to be the integral from 0 to 1/2 of g of x sine pi x minus 8x cubed dx. And I'm going to go ahead and let u equal pi x. du is pi dx. Now in this case, you know what? It actually, yeah, I can go ahead and do that. So this becomes the integral of sine of u. I'm going to put in a pi. Take out a 1 over pi. Sine of u minus 8. Oops. I can't do that because of subtraction. I'm going to have to split these up. Sorry about that. I should have caught that right away. Sine of u, and then this pi dx is going to be here. So that would be du minus, and I'm going to leave this guy alone, 0 to 1/2, 8x cubed dx. And so this is going to be 0, goes in for x, so that's going to be 0. 1/2 for x is going to be pi over 2. Does that make sense? So yeah, I should have split these up first instead of trying to put the pi in here, because then my x, what do I substitute for x? It makes it too messy to do that. So if I split them up first with this, when there's subtraction, then I just keep them as two separate integrals. So then this becomes 1 over pi. Integral of sine is negative cosine u from 0 to pi over 2 minus, this becomes 8x to the 4th over 4, which is 2x to the 4th from 0 to 1/2. And if I scroll up, I've got 1 over pi times negative cosine of pi over 2 minus negative cosine of 0 minus 2 times 1/2 to the 4th minus 2 times 0 to the 4th. So you just got to be careful as you're going here. Cosine of pi over 2 is 0. Cosine of 0 is 1. This is minus. Minus is plus, so it would be plus 1. Minus 1/2 to the 4th. 2 times 2 is 4 times 2 is 8 times 2 is 16. 2 over 16 is 1/8 minus 0. So it looks like we've got 1 over pi minus 1/8. Okay, there we go on that one. Okay, and then we've got C. Write but do not evaluate an integral expression. I'm going to erase some of these guys. For the volume solid when r is rotated about the horizontal line y equal 1. So I'm going to take this line y equal 1. So y equal 1. Oops. Where's y equal 1? I got to draw it in the right. I'm just going to draw it down below. Y equal 1 is this guy right here. Okay. And when I rotate that, here, let me draw it down here. It's going to go like that and that. And so you've got to recognize that shape right there. Okay, that nice little washer there right in the middle with thickness delta x. And if I go in the middle and I say, okay, what's my piece of volume in there? Or it's going to be a washer, and it's going to be pi r squared minus r squared delta x. So I always draw down to the function. That's my capital R. So capital R is going to be pi times 1 minus, this bottom function is f of x squared minus little r is this guy here, 1 minus g of x squared dx. That makes sense? So that's going to be, so the volume then will be pi times the integral, and again my washer moves from 0 all the way over to 1/2, 0 to 1/2 of 1 minus, and then fill in what f of x is, 8x cubed minus 1 minus sine of pi x squared dx. Okay, there you go.